the previous lecture we have discussed the conductive ink, now we discuss the semiconductor ink, which is also the core component of the printed electronic devices and largely determine the performance of the final devices. Means we choose the semiconductor ink on the basis of its performance, and we offer this ink divided into the two categories. One is organic or second is the inorganic semiconductor ink that will be used for the next generation two-dimensional material ink. Means inorganic metal oxide ink and the organic semiconductor ink offer the consistent properties such as mobility and the band gap, which provide the reliable performance of the printed organic light emitted diode and the field effect transistors and organic solar cell. Means we are using the organic ink for the organic OLED, FET and OSCS devices. Emerging two-dimensional nanomaterials ink offer the direct band gap, low defect, ease for the fabrication and opportunity to fabricate the novel vertically integrated next generation electronic devices. Means we can prepare the electronic two-dimensional, we can prepare the fast and efficient devices, fast performance, that will give the fast performance as well as the efficient device by using the 2D nanomaterials for the semiconductor. It may be the organic or the inorganic, and these ink are designed to have the specific semiconductor properties, and they are used in the application for the preparation of the thin film transistors, organic photovoltaic cells, OPEVs, that will be used for the solar system. Organic semiconductor inks made from the organic materials, and these inks are used for preparation of OLED, organic electronics, and moreover organic photovoltaic cells and other devices. If we talk about the inorganic semiconductor ink, and these are typically based on the material like copper oxide or the zinc oxide and are used in the more specialized applications. So now again we discuss the type of the semiconductor ink. If we talk about the organic semiconductor ink, it is having the material composition with the small molecules and which must be a polymers also. Advantages, if we talk about, it is a solution, processable, flexible and low cost ink. What are the challenges? It has a low mobility than the inorganic semiconductors ink. Application, as we discussed, that it is used in the flexible transistors, OLED sensors, we can use this ink. Another type of ink is the inorganic semiconductor ink. That must be the metal oxide, ZNO, SNO2, IN2O3 and the quantum dot. This is the inorganic semiconductor ink. In the quantum dot we can take the PBS, cadmium selenate, cadmium sulfide, and we can take the another indium, we can take many type of the quantum dot. So it is having the high stability, higher mobility, higher curing temperature, complex processing, these is the challenges. And if we talk about the advantages, then it is a printed transistors, photodetectors, which displays and which is used for the display devices. Next is the hybrid semiconductor ink, that is organic, inorganic, perovskite and many other inks. We can just get a combination of this, which is having a high efficiency, which is a tunable properties. Tunable properties, as we are just taking the 2 or 3 inks, so they can be tuned accordingly. They are the stability, they are having a stability issues, toxicity. So these are the challenges with this type of ink. We prepare the solar cell, photodetectors, LEDs by using this hybrid semiconductor ink. Another type of ink which can say, that is a carbon based semiconductor ink. That carbon based semiconductor ink is having the various carbon materials. That materials are graphene, carbon nanomaterials, CNT and reduced graphene oxide and many more. So high flexibility and printable, and their challenges are process control needed for uniform properties. Application, again we can prepare the sensor, neural interfaces we can prepare by using this carbon semiconductor ink, and flexible transistors we can prepare. Again, these are the key properties of the semiconductor ink, as it is a charge carrier mobility, it determines the switching speed, and the typical value is defined here, 10 to 100 centimeter inverse per volt second. So, this is for the inorganic and the inorganic. Both the range has been defined, 0.1 to 10 and 10 to 100. Band gap energy, we define the electronic behavior. It must be in the range of 1.1 to 1.123 electron volt. That must be the band energy for the semiconductor ink. Curing temperature, which affects the substrate capability, that must be 80 to 300 degrees centigrade. Stability, impact device lifetime, and moreover the organic having the less as compared to the inorganic stability. Flexibility enables bendable electronics and high for the organic and the CNT. Means CNT and high and organics are having the high value as compared to the inorganic, that is a more flexible. Enables the bendable electronics, can be used for the any substrate which is flexible for the printing purpose. Next is the printing methods for the suitable semiconductor ink, in which we can use the inkjet printing screening. So, if we take the inkjet printing, we use the organic ink, in which we can use the ZNO or the CNT. Screen printing, for the screen printing we use the perovskite as well as the metal oxide. Advantages for both are high precision, low material waste in the inkjet, but in the screening as we require the thickness of the film. So, in the screen printing we use the metal oxide for the thickness, and it is must be scalable. Or if we talk about the applications, in the inkjet printing we have a flexible transistor and sensor we can prepare. If we talk about the screen printing, we have the printed solar cell and LED. Another type, aerogel jet printing, we use the graphene, we use the CNT and quantum dot. 3D patterning we can get, ultra fine lines we can get, wearable, biosensors and photodetectors we can prepare. These are the application of this type of aerogel, of this type of semiconductor ink. Now, another printing, that is the flexographic, that is the organic semiconductors that is used for the printing in the flexography. So, in the flexography we use this organic semiconductor ink, and that is on the roll to fast production. So, RFID printing logic circuit we can do by it. Choosing the right semiconductor ink, which is also important. If we talk about the flexible and wearable electronics, you can see on the screen we can use the organic semiconductor ink. Another is the for high performance transistors displays, we can use the metal oxide. Examples are also here, ZNO, SNO2 and another. If we talk about the solar cell or LED preparation, so we can use the perovskite semiconductor ink. Another, for transparent and flexible devices, we can use the carbon based ink, that must be the graphene as well as the CNT and the quantum dot. Another type of ink is the dielectric ink. Up to now we have discussed the insulating ink, we have discussed the semiconductor ink, now we discuss the dielectric ink. This is also a very important, this also play a very important role in protecting and enhancing the operation of the conductive materials, completing energy storage devices and enabling electronic devices that operate under a biased voltage. So, whenever we prepare the electronic devices for the energy storage purposes and which is under a biased voltage, then we use the dielectric ink. That plays a very important role for the electronic devices. Our dielectric ink are composed of organic polymers or the ceramic in the solvent. Means we take the solvent, then we having a organic polymer and ceramic that must be dissolved in the particular solvent. And the novel insulating 2D nanomaterials such as hexagonal boron nitride to provide the temperature and electrochemical stability, which are very important for the solid state batteries. Electrochemical stability is required for the storage purposes, so we use the dielectric ink. And we prepare the field effect transistor. Moreover, we can prepare the another type of devices for the for this dielectric ink. Now, dielectric inks are used to create the insulating layer that prevent the current leakage. Means we prepare a insulating layer, or we can use it for the connecting as an insulating layer that prevent the current leakage between the conductive parts, and they are essential in the fabrication of capacitor and other component requiring the dielectric materials. Polymer dielectric ink, we can use ceramic based ink we are having, which often used for capacitors or insulating layer in the flexible electronics. Moreover, ceramic based ink, these are used in the application where the high temperature stability and high dielectric constants are needed. Again, I repeat that the ceramic based ink we can use whenever we use the high temperature stability, and whenever we require the high dielectric constants, then we use the ceramic ink. Then we are having the comparison between these ink, polymer based as ceramic, polymer based epoxies. Polyamides are used for this. Acrylics we use this polymer based ink. Advantages, it is having a flexible low temperature curing as a temperature curing, and the challenges, low thermal stability as compared to the ceramic. We can prepare variable electronics, flexible circuits and etc. If we talk about the ceramic based, alumina, barium, titanate, we can use silica for the high temperature stability, low dielectric losses. It is brittle, higher curing temperature, so these are the challenging for this ink. And application, again high frequency RF circuit antennas we can prepare using the ceramic based ink. So another type is the hybrid, where we just mix the polymer as well as the ceramic blends. So this is the type of hybrid ink where we just mix the polymer as well as the ceramic. Moreover, advantages if we talk about, then it is the balances the flexibility and the thermal stability. Again we are using the ceramic, so it is the thermal stable. So we can use for this purpose like 3D printing, or for the multi-layer circuits we can prepare by this hybrid ink. We can just prepare a device layer by layer also. There are challenges, it is having a complex formulation, or moreover the choice is very important here. So what are the key properties of the dielectric inks, where we have the dielectric constant, which is the most and prior property for the dielectric inks. It must be 2 to 10 depending on the material which we are using. It determines the capacitance and insulation efficiency. Breakdown voltage, it prevents the short circuit, which must be less than 50 volt. So it must be greater than 50 volt per micrometer. Curing temperature affects substrate capability. Compatibility must be 80 to 300 degrees centigrade. Means the temperature of any electronic circuit which is working under this temperature can be prepared by using the ceramic dielectric ink. So up to 300 degree temperature it can be used. Adhesion strength, ensure the durability on the substrates, it must be strong. Glass, we can take it from this. Flexible, it enables the bendable or the stretchable. Electronics, high for the polymer based ink. For the flexibility, if you take the polymer, then it is more flexible as compared to the other ink. So polymer inks are used for the flexible devices. Thermal stability as used up to the 400 degrees centigrade for the ceramic determines the long term reliability. What type of printing techniques we can use for this? We can use the various printing methods for this, in which we are having the screen printing. That in this screen printing we use the polymer based polymer based or the hybrid ink, and as we require the thickness and it is a cost effective, moreover the application again flexible or the sensors or the circuit as per the requirement. Inkjet printing which requires the low viscosity and polymer ink, so we can take the polymer ink for this inkjet printing as it is having the low viscosities. We are using the printing, so we have to put in the cartridge and the flow should be a smooth drop on drop demand, as we have seen that we are having a very good flow. So, in this case we have a low viscosity, and for this we use the polymer type of material. High precision multi-layer design we can do, transparent insulations and touch sensors we can prepare by the printing. Aerogel printing we can high performance polymer and the hybrid ink we can use. And 3D patterning, ultra fine lines we can prepare. Aerospace biomedical electronic devices we can prepare by this dielectric ink using the aerogel printing. Flexographic printing, fast drying polymer inks we can use, and moreover smart packaging printing capacitors we use, and it is having a high speed roll to roll production as we are just getting the number of devices at the similar time, so we use this. What are the right choice for the dielectric ink? For the flexible and wearable electronic devices we use the polymer based ink, acrylic as well as a epoxy we can use for the flexible and wearable electronics. For high temperature or RF we use the ceramic based. Multi-layer and 3D circuits we use the hybrid ink. We can prepare the multi-layer 3D circuits by the hybrid or the polymer ceramics. Another type of ink is the insulating ink. These inks do not conduct electricity and are used to create the non-conductive region in the printing. So in the printing electronic devices, insulating ink are used whenever we just create a non-conductive region in the printing electronics and acting as a barrier between the different conductive layers. Means whenever we do not require any conductive region, so we use insulating ink that will produce the barrier in between the conductive devices. So, polymer based insulating ink we can use here, epoxy based ink we can use for the insulating, or we can use the hybrid ink also. These are, if we talk about the polymer based insulating ink, these are typically used in the flexible circuit to prevent the unwanted electrical connections between the conductive traces. Epoxy based ink, these are more durable and can be used to insulating components that will be exposed to harsher environmental condition. You can see material composition as well as advantages, challenges and application again. So, polymer based epoxy and acrylic and polyamide ink we can use, flexible, low curing, and we can prepare the flexible circuit sensor, wearable. Challenges, having a lower thermal resistance. Moreover, the ceramic based ink we can use with the high temperature stability, excellent insulation, we can have the high frequency devices, RF circuits we can prepare by using this ceramic based ink. UV curable, that is the acrylics and the silicones, that the fast processing energy efficient, limited thermal stability, moreover having the application of the rapid manufacturing 3D printing electronics. Hybrid ink, that must be polymer plus ceramic, that is balances the flexibility and the thermal stability. Complex formulation, high performance multi-layered devices we can prepare by using this insulating ink. These are the key parameters which keep in mind whenever we choose the ink: volume, resistivity, breakdown voltage, dielectric constant, curing temperature. Again, the curing temperature is similar as we have discussed in the dielectric ink, that must be the 80 to 300. Dielectric constant must be 2 to 10 and determines the capacitance and insulation efficiency. Moreover, breakdown voltage again is a which prevents the shorter circuit, and volume resistivity which ensure the electrical insulations. Again, these flexibility, adhesion strength and the thermal stability. These are again these parameters as we discussed, these are similar as we use in the dielectric constants. Again we can do the different type of printing like screen printing and inkjet printing. If we are doing the screen printing, then we use the polymer based as well as the hybrid ink. If we are doing the inkjet printing, we use the low viscosity polymer ink. As screen printing advantages is the thick layer, cost effective, and encapsulation we can done by using this insulating, and moreover the protective coating we can do whenever we are not required the conductive materials, we can do it from this method. Another is the inkjet printing where we are having a high precision multi-layer design. So transparent insulations, touch sensors we can prepare by using the inkjet. Aerogel, high performance polymer and hybrid ink that must be used for the 3D patterning, and moreover the ultra fine line. Flexographical, again the fast drying polymers, that high speed roll to roll production we can do. Again what is the parameter to choose the right, that we have discussed. Now how we choose the right insulating ink for the right devices. So for flexible and variable electronics we use the polymer based ink, and for the high temperature and RF application we use the ceramic based ink. For the fast high throughput manufacturing we use the UV curable insulating ink. For multi-layer and 3D circuit we use the hybrid ink, that must be polymer or the ceramic. So these type of inks we can use. Another type of ink is OLED or display ink, that ink design for the manufacturing of the OLED display and the similar technology, including the material that can emit light when stimulated by the electric current. And for this it will use the massive ink or as well as the quantum dot ink. And these ink includes the organic material, as we already discussed that we are having a different type of organic and inorganic material ink. Quantum dot ink, they are used for the advanced displays where the quantum dot are embedded to improve the color rendering and the brightness. So nowadays OLEDs are prepared by using this type of the ink. Another type of ink is the thermochromic ink, and this ink change the color when exposed to the heat. This type of ink are used in the sensors, packaging and even in the smart textiles. Means whenever it exposed to the heat, it will change its color. Organic thermochromic ink often used to low cost application where the temperature monitoring or the control is necessary. Another type is the inorganic thermochromic ink, and this offer the better stability and durability for the high performance application. Another type of ink is the electroluminescent ink, and these ink are used in the application that requires the light generation. Have you seen that sometime when the light fall, it will just blink or it will give the shine, such as the backlighting for displaying, or a various technology we can use in this electroluminescent ink that can emit the light when a voltage is applied. So polymer based electroluminescent ink often used for flexible displays, and their light emitting properties are based on the organic component. Another type is inkjet printable ink, that is a particular type of ink that is used for the inkjet printing technology, only for the inkjet printing electronics. That is the conductive inkjet ink, and that is the functional inkjet ink. So conductive we have discussed, it is a copper base, silver base, and the functional ink are which is having a application for the sensor, transistor and a photovoltaic cell. Another type of ink is the photoresist ink, and that is used for the photolithography processes. And this type of ink are very sensitive to the light and can be used to define the patterner that for the circuit traces on the PCB and for the another devices. This photoresist ink are of the two type. First is the positive photoresist and next is the negative photoresist, and these ink become soluble when exposed to the light and allowing for the creation of the pattern. And another type of ink is the negative photoresist. These ink hardens when exposed to the light and leaving behind a non-exposed area. And this hybrid ink combines the organic and inorganic material to achieve both the conductive and insulating properties and to improve the mechanical and electrical performances. So, silver nanoparticle based hybrid ink, which combines the advantages of organic polymer as well as with the inorganic metals like silver, copper to improve the conductivity and flexibility. Another type of ink which used only for the storage devices that create the component of the electronic storage devices such as the batteries and the supercapacitors, and which is used for the fabrication of the electrodes in the batteries or the supercapacitor, typically involving carbon, graphene and the other conductive materials. So, lithium based ink, these ink can be used for printed lithium ion batteries in the flexible electronics. So, finally, the choice of the ink for printed electronic depends on the specific requirement of the application such as conductivity, flexibility or light emission properties. The most commonly used material include silver, copper, carbon based ink and the organic or inorganic semiconductor, while newer innovations like graphene and carbon nanotubes are also gaining the attention for their superior properties. So, keep in mind the device which you are preparing, the application for which the device are preparing, we choose the ink. So, the choice of the ink must be depend upon the end output. So, thank you very much. In the next lecture, we will discuss further the substrates we use for the printing purposes. Thank you very much.